Okay, so today's lecture will be just going to the basics and will not be doing much of the coding part and just try to get over the theory part first, and then by tomorrow we'll be starting the coding, like utilization of basic queries. But as of today we'll be understanding the basic concept on which we are going to like build this whole uh, sessions. Okay, so this particular session will be about SQL, and when I say SQL, it's basically a language that is going to be used. It's like you have used Python, C language, and Java. Many more languages are there. Similarly, SQL is a structured query language. This is also a programming language. So before moving into further what it means and what relational database management and all those things mean, let me tell you one thing is that we are surrounded by one thing, and it is called as data. Any information that you see around yourself is data, be it in the form of videos, photos that you're circulating on WhatsApp or YouTube, anywhere. Even the content that I'm speaking, and even the content that you're seeing, anything, any information that is being circulated or that is being used is called as data. And when I say database, means a collection of data in a meaningful form. So when you collect all these data, suppose there are on internet there are plenty of data available, but if I group all the data related to SQL into one particular box, then it is a database for SQL. So it is a base where data is being collected related to some specific area or some specific criteria, on the basis of some specific criteria. So they, and then arises a question: what are the different types of database? Because since we are categorizing the data, or we are clubbing the data into groups, so what could be the different types? Okay. So when coming to types of database, we can say there are two types of databases. First is relational database. When I say relational, means there are certain relations that is existing between these data. And when I say relational database, then definitely there should be some databases in which there is no defined relationship. So those type of databases are called as non-relational databases. Now we have data clubbed into database, and we have categorized into relational and non-relational. Now there should be some system to manage this databases. So if you're managing a relational database, we call it relational database management system. And if you are managing something that is non-relational, it is called as non-relational database management system. Management system is the two different words that is being added to database name to suggest that, okay, this is a system in which you are going to manage certain data. So there are few commands that you will be using. Okay, let me run this query so it will be much more easier. So I suppose you have watched the previous video in which I have exactly told how to install this thing. You can download any ID, you can even use MySQL. So I'm using this SQL Server from Microsoft. So here onto the left side, you can see there are multiple
Sorry,
data.
sorry, but we can't see the screen. I think it's stuck in that
Okay, okay.
SQL screen.
Yeah, thank you so much. I'll just reshare. Is it visible? Okay,
Yes.
so onto the left side, you see there is a databases here. So there are certain like inbuilt databases available that can be used directly. So here we have master, model, MSDB, and then we have temp DB. So to know exactly what are the different databases available, we can use the command show databases and then semicolon. This is to check all the databases available, but since we are already seeing here, I'll not use this show one. I'm going to create a database of my own. So I'll use create database and the name of the database. Suppose my database name is student. So this is a database which is going to have data related to students. So I'll click on execute and you see I have got a message that commands completed successfully. Just a second. So I have got a message command successfully run. So I have used two keywords. First is create and second one is database. And then you write student or the name of the database. One thing you should take care is the SQL, like unlike Python is a case sensitive language in which whatever you write in a small letter is treated differently. And if you write in capital letter, but that is not case with SQL. You can write either in small letters or you can write in capital letters. It does not make any difference. So I have written create, but at some position you might see people writing all the keywords in capital letters. So it's okay. You can use capital or small. It's all up to you. So I have used the statement create database. So this is going to create a database. So I'm going to refresh here and you see a new database student is available here. So if I want to use this database, I'll give the command use and which database I want to use. So I want to use student. Okay, I don't know why it's giving error. I'll check it later. Okay, so use command is to actually utilize this database, and to delete we can use drop or delete. So I'll just copy it. So to drop a database, this is the syntax: drop, then we use database keyword and the name of the database. In this case, our database name is student. Now I'm going to run it. Okay, so it cannot be dropped because it's in currently use. So okay, so the system is using student as of now, that's why it is not dropping. I'll select some other database. Okay, use database. I'll use master semicolon. So yeah, I'll try dropping. I'm getting some error in this IDE. Probably I have to reinstall it.
Same
Yeah.
here, like even I'm getting the same error.
Yeah, it's I don't know, it was working properly in the morning, but after I tried to reinstall it, I think I have not done it properly. Okay, no issues. I'll try it today or tomorrow and then see what's happening here. So coming back, like this is the command to like create a database, and this is to drop a database. And whenever you want to switch between different databases, you can use command, and this is again the drop database. So these were the four basic commands, and one different one is you can even use select a database to see which database you are working with. So let's see if this works. So this is a function. Okay, again incorrect syntax.
You can do start, no, star, select star from master
That is basically
for all, right?
done for tables. So okay, no issues. I'll see it and check like what exactly. Probably there could be some issues with the installation, or I have deleted because I have reinstalled it twice. So probably there could be some files.
So even I'm getting the same error bridge.
Okay, don't worry. I'll exactly go through it once and just tell what exactly to be done. No issues. Okay, I'll again start with the other topics, and then tomorrow when we are going to do the coding part completely, we'll do it again. Okay, so again, so what is relational database management? As I said, when there are certain relations between two uh, like between your data, so it is called as relational database management system, managing your database which has some certain relations. So when I say relations, how can possibly that happen? To understand this, let's understand there is a table. It is when I say table, just uh, consider it similar to the Excel, Microsoft Excel sheets. So I'll draw a table for you here. Suppose this is a table, and here I'm going to make the name of the heading as student ID. Here it is name, and then we have gender, and then we have age. So this is a table where I'm going to write name, oh sorry, student ID is 1 2 3 4, and then 5 6 7 8. So student ID is basically like roll number. It is a unique, and for each student it is unique, so we cannot repeat it. So I'm just coloring it in a different color. That means okay, this particular column is a unique value. Then we have name. So name can be same, like in a class there can be two students with the same name, so it is a coincidence that it is possible. So I'm not coloring it because it is possible that a duplicate can happen over here. Similarly with the gender, and same goes with the age. It's not specific that one person is of 24 age then other cannot be. So in this thing you see there, this is a table, right? Just a second, somebody's wants to, yeah. So this is a table, and in table there are certain rows and certain columns. So each column is having a relation with the other column, and similarly we can say one row can have a relation with other row. So it is like having a connection with one other, like one data is having a connection with other data. So this is relationship. Let's take an example. Suppose there is a table called a student. It has different columns such as student ID, student name, student major. Major is basically like PCM or PCB. PCM stand for physics, chemistry, math, or PCB for bio. And then we have students email. Similarly, there is another table called as grade. In this, we have student ID, course ID, and grade. Then we have another table as course, and then another table as classroom. Now you see the student table and the grade table is connected by one single column, that is student ID. So every student in a given class will have certain specific ID, and same goes with the grade. If you want to check like what grade a student has got, we can check it by student ID. And also there is another column called as course ID, which is connected with another table called as course. So one table can have a relationship with other tables. So these are the relationships that is to be taken care of. And while making these relations, there are certain things that we can take care of, like primary keys and secondary keys. We'll cover it at some like tomorrow, or I think we'll cover it today itself. Then we have queries. What basically queries means? So when I say queries, it's like asking certain questions with a database. So when I okay, so if I say database, just imagine a library and all the tables. Just a second, please. So queries is basically all the questions that is available. So you can consider a library, and a librarian is standing over there, and all the books over there are one particular of genre. Suppose one could be fiction, other could be love stories and all. So when you go to library, you are going to ask for a novel. So you will ask, okay, I want a romantic novel, or I want a science fiction. So in the science fiction table or in the science fiction rack, there will be multiple books. For each book, there will be a number that represents that particular book. So you will ask, okay, please give me this particular book. So he will go and check whether it belongs to a romantic novel or it is belonging to sci-fi novel. Once it is clear to which section it is, then it will go for like which particular book number it is. So one example is that. Second example, we can take like how many students in a class are like qualified for, or we can say have got certain grades in a given subject. So this is another level of question. So queries basically means the questions which you are going to ask from database, and that database is going to give you some answers on the basis of data or some constraint. Constraint basically means certain set of rules that are applied on the database. Suppose let's the query is, I want the name of all the students whose age is greater than 25. So the query is to get the names of the student, and the constraint is that age should be above 25. Okay. There could be another constraint that email ID cannot be empty or null. Okay. When I say null, it means it cannot be left empty. So in that case, it is a constraint. Okay, I cannot leave empty. I cannot leave the roll number empty. When I'm going to give an exam, I cannot keep the roll number section like empty on while filling some forms on Google or anywhere. You might see asterisk marks are put over the columns or over the fields which are mandatory to be filled. So that is a constraint. You cannot keep that thing empty or not null. These are not null. You cannot keep it as an empty. So to interact with the database, we need some language, and that language is SQL. SQL is structured query language. MySQL is not a language. It is a relational database management system. Okay, that is helping you to query the database through a language that is SQL. DB2 is another example. It's IBM's platform. So, similarly, there are many more. So SQL is one such language which is going to be used to make the queries, okay, or ask the queries or ask the questions from the database. Now there are different categories in which you can divide your commands. So I will cover three basic categories. One is DML, then we have DDL, and then DCL. Data manipulation language. So these all three parts are the subcategories of SQL itself. Just we are categorizing all the commands on the basis of their functionality. So data manipulation language will have all the commands which are going to manipulate the data. Then data definition language will have all the commands which are going to help you to define the database or define the new data set. And then data control language is the set of commands which are going to apply some constraint or apply some conditioning on the question. Let's take an example. Suppose manipulation language, I want to modify the data. Suppose you want to update the data set, you want to alter the data set, or you want to delete some rows from the data set. So what are you doing exactly? You are manipulating with the data set. Then we have data definition. Suppose there is no data set and about the students, and you want to make one data set about the students. So it is giving you liberty. This data definition language is giving you liberty with certain commands that is going to help you create new data set or create new tables. Similarly, data control is going to help you put some restrictions over the databases. When I say data, it means any meaningful information. It can be in any form, written form, text form, videos, anything, pictures. So when I say data, it should be of certain types. We have covered data types in Python as well. So data type basically means what type of data you are dealing with. So it could be integer. Integer means a positive or negative number. So if it is roll number, let's take an example of roll number. If we take an example of roll number, so what is going to happen is whenever you are going to enter the roll number, you cannot enter A, B, C, D. Okay, there are possibilities, but in general, if I say roll number, it is some integer values. So I'll write it's integer. Okay, so it could be positive number or negative number. Then we need sometime decimal values. So in that case, we'll be using number data type. So here the syntax will be, suppose I want marks, so it will be number type, that it can have decimal values or the percentage. Let's see, suppose the percentage of a student, so it could be of number format. 9,3 basically means represents like how many characters or how many digits in total should be there. So total 9 and with 3 decimal points. So something like that. Similarly, if you want a single character like male or female, then you can use char. But if you want to input or if you want to make a data of larger characters, suppose a name or address or email number. So in that case, you need multiple characters or a string. For that, we use varchar. So varchar, and then this is you give like the how many number of characters or how many number of alphabets, special symbols, or anything that you are going to allow. So varchar 30 means max to max we can use 30 characters in that name. Okay, so let's take an example. I'll write name, then varchar 30. So this means I'm going to make a variable of variable called as name, which is going to store string. Since I've used varchar, it means it's going to store a string of length 30. Similarly, there is another data type called as date, which is going to like it's the name says, it is going to store dates. So we'll be seeing how what is the basic query in SQL looks like. So it is just like plain English, like just like the Java, the Python which we did, it was plain English. Similarly, SQL is also a plain English language. So if you want to select certain things from a given table, you will use a simple command as select star. Basically means all the rows, all the data available. Select star means select all the rows from which particular table. So in this case the table name is customers. So select all the data from customer table where. So now this is a condition. Okay, this is a condition that we are going to put. Select all the data on the basis of this condition. So condition is where the country is USA and semicolon is to end. So at certain places you will see that semicolon is mandatory, and at some places you will see it's not mandatory. So do not worry, it is like most of the cases, 99% I am sure that it is going to be same syntax everywhere, same commands everywhere, only a few will vary. So do not worry about that. If it is giving you error, then definitely you can google it, what is the real command for that particular database. So in this star basically refers to all the rows or all the data sets. Now again, coming back to relational database management system. So in this, we are going to organize data into table form, that is already told. Each table, each table is going to have a specific key. When I say specific key, it means a specific column that is going to be unique. So in this table of student table here, student ID is unique. Okay. So this is a key. So key means this is specific to that particular table only. So it is very unique to that particular table. So each table is going to have one or more unique key. Okay. Then we have in table, we have what is table? Table is basically collection of rows and columns. So columns is vertical entities, and when we say rows, it is horizontal ones. Okay. Keys could be like I said, student ID. These are the unique. Okay. And it could be one single column, or it could be combination of one or two columns. Okay. Then we have relationships. Relationships basically like how one column or one table is depending on other table. In this example, we have seen student, grade, course, and classroom. These are four different tables, and how each table is connected with each other. So grade is connected with student by a single column name called as student ID. Similarly, course ID. So here you see the grade has two different columns as unique key. So that is why I've said when we say keys, it could be single column or a combination of column. Then understanding the relational model. So it is basically a way of organizing your data. It is a way in which you categorize your data and then organize your data in database, so that it is easier for anybody to fetch or to get the data out of that database. Okay. So when you are going to organize your data, let me give a scenario where suppose the name of the student is like data related to one particular student is entered two times. So it is redundant data, like it is creating one extra rows, and that is useless because same row is already entered over. So let me give you example here. So in the previous table, suppose this data here, I'm again entering into. So these two data sets are same, although student ID, okay, this is again here. So first thing, it is wrong because student ID should be unique. So I have two different rows having same student ID. So it cannot be possible. And also the data is getting repeated. Even if here by mistake I have written different ID, but other columns are having same set of data. So this is redundancy. So because this set of data is getting repeated under different student ID, but both students are same. So this is not a good practice, or this is not a good way to represent your database. So what do? We do the normalization. Is a process. This is a process where we organize our data and reduce redundancy and improve data integrity. Let me show you an example here. So suppose this is a table, customer ID, customer name, order ID, order date, and order total. So you see this particular row 1 and row 2, these are having different order ID. Like order ID is different here and order ID is different here. But what is same here? The same customer. So no need to write different times. What we can do is we can make two different table, one with a customer name and customer ID, and then we can make another table as order table. So this is way where you are splitting one single table into two different table, where same redundancy is reduced and the way your data is getting arranged is more neater than the first table. So here you can connect. So you see order ID 100, customer ID is 1. So you can go back to customer table and see the customer ID 1 refers to what particular name. So it is referring to John Smith. So okay, so this order ID is related to John Smith. Then again we are coming here, customer ID is 1. We are going back here, so we can check, okay, so this particular ID is also related with John Smith. So by that way, we are splitting one table into two different table and reducing the unwanted cluttering into our data and making it more cleaner. As I said, like there are three different ways, three different types of categorization of our language, SQL. So one is DDL. So DDL basically refers to data definition language. So there are certain commands which we'll be practicing tomorrow, but today we'll just go through a bit and understand what basically DDL looks like. Okay, so there is a command for creating a table. So what is the syntax to create a table? You write create and then table and the name of the table. So this is general syntax. You write create command, then you write table command because you are creating what? Table. And then you write the name of the table, then bracket. Then what are the different columns you are going to make into that? Column 1, and then what type of data it is going to contain. So this is the basic general syntax. So let's take an example to create a customer database, sorry, customer table with customer ID, customer name and email address. Okay. So in this we can write create space table and the name of the table is customers. Then we will use a bracket and then customer ID is one column here. And then what type of data it is going to store? It is going to store integer type of data. Then we have primary key. So primary key is basically a constraint. So not constraint. Yeah, sorry. Yeah, primary key is a constraint. I'll cover it in a bit. So primary key is a constraint that says this particular column, that is customer ID, should have unique values, that it should not repeat. One customer will have one particular customer ID, and second thing, it cannot be null. You cannot keep a column null, or you cannot keep duplicate data if you have written primary key in front of that. Second column is customer name having varchar 50, that is it is going to store the name, and third is email. So what the system is going to do is it is going to, as soon as this command is run, it is going to create a table with three different columns. Okay, three different columns. First is going to be customer ID, and this is going to store data of what type? Integer type. Then other column will be customer name, and it is going to be string type, and the length of this will be 50 characters at max. And the third will be email. There are different ways where we can put a constraint that it should, you can check whether it is that email is entered in a correct format. Like every email has @ symbol. Okay, so there is a method, a constraint which you can use here that will check whether the email address entered by the user is correct or not. Okay, it will, suppose any email ID is going to be something @ something dot add something. So it is like alpha @beta dot gamma. So here could be anything, here could be anything, and after this dot full stop there could be something. So our syntax is, okay, if anything is written as, anything is written, then we have @, then anything, then we have anything that is written, any syntax or any string, then we have a dot and then certain characters. So star basically refers to any number of characters here. So this is one basic check. Okay, if it is fulfilling that condition, so this is certainly a good email. Okay, so email, here we have string, and it is also going to store 50 character at max.
So,
So
Bridge, I
let's,
have a question.
yeah.
So, in this case, if we are going to link this table with other table, and the community is the customer name or customer ID, then customer ID or the customer name is the primary key, right? Is my understanding correct?
Sorry, your question was not clear.
So suppose we are linking this table with other table,
Mm-hmm.
and so we have both in both table we have customer name. Okay, in
Okay.
that case, customer name is the primary key, right?
Customer name can be primary key, but it is not a good practice to make customer name as a primary key because two people can have same name.
Yeah, just
Better
an
to
example
make.
I'm telling for my
Yeah.
understanding.
Yeah. So suppose customer ID, let's take, instead of customer name, let's take it customer ID for one table. Okay.
Okay.
Let's take this example itself. So customer ID here is a unique key. Okay. And in this case, customer ID here is a foreign key. Foreign key means this key, this particular column is a primary key in some other column and in some other table. Okay, just
Linking.
yeah, we can link it. We can link it.
Okay, got it.
So when I'll cover this foreign key, I'll tell how exactly to link it. Okay. So this primary key is a constraint. Okay. Let's see what are the different types of constraint here. So we write create command, then table, then name of the table, then column name, and what kind type of data it is going to have, then constraint we can write, then separate by commas. All the different columns can be separated by commas. uh, so this is same one, order date as a date type. So this is one basic example where we have primary key and foreign key as well. So as I told, foreign key in, okay, so the first table was customer and second table is orders. In orders table, customer ID is a foreign key, and that is referring to which table? That is referring to table customers, and in customers table it is referring to column customer ID. So let's understand each line one by one. Before moving that, just keep this particular table in mind. So first table is, okay, let me copy and paste it so it will be easier. Yeah, so can you see these tables here? Yeah, so you see
Yes.
here customer table is here. It has two columns, customer ID and customer name. In the customer table, customer ID is primary key. When I say primary key, it is the unique column that is unique to column customers. Then we have another table called as orders. In this table we are using customer ID. So basically customer ID is coming from where? It is coming from customer table. So this is not a original column, it is a borrowed column. You are borrowing it from customer table. So that is why it is a foreign key. A foreign key is basically a primary key to some other table. A foreign key, here customer ID in order table, is a primary key. This customer ID is a primary key to some other table. Other table is customers here. Am I clear?
Yes. So the initial one is the primary, and what we're linking is the foreign key.
Yeah. So
So
you are
the
linking foreign with this primary.
primary key.
Yeah.
So in this table, the first one, customer ID in the first table top is the primary key, and the second table, customer ID is the foreign key.
Yes. So to mention how it is, to mention that, you write foreign key, that is the keyword. Now which particular column is a foreign key? So customer ID is foreign key. Okay. And this customer ID is referencing back to which particular table? This is referencing back to customers table. So here it is referencing back to customers table, and in customers table, that basically is customer ID. So why we are writing here? It does not it's not compulsory that you have to mention same name here. Suppose here it's CUST ID. I can write it CUST ID, and here I can write customer ID. So if that is the case, I have to write here CUST ID. So that means basically in customer table, CUST ID is same as customer ID in orders table. So that is the interpretation of this particular line. I hope I'm not making you confused. But if it is that,
No.
if it is the case, don't worry. When we are going to write the codes, we'll try to make one set of table, and we'll try to understand how it's going to work. So let's see, there are different constraint. Primary key and foreign key was one such. So there is not null. So you see here, I have mentioned first name not null. So it means that you cannot keep it blank. You have to enter some value. Does not mean what, but you have to enter certain values into that. You cannot keep it blank. So this is one constraint. Then we have unique constraint. Unique means something that is not repeated, or that is unique to some that particular column. When you are going to make email on Gmail, like signing up in Gmail to make email, so you try, it gives you some suggestions, and if you want to check that it is working for you or not, when you enter it, Google will tell exactly whether that particular email is taken or not. If it is taken, you have to choose another one. So each email is unique. No two-person is going to have same email. It is like fingerprint. So it is unique. Coming to primary key. So primary key is a combination of above two. If you do not write primary key and instead you write not null, comma, unique, in that case it is basically referring to same as to primary key. Okay. Sorry, where is my cursor? Yeah. So primary key is basically a constraint that tells, okay, this particular column is uniquely identifying this table. And foreign key is basically a primary key of some other table being represented in this table. So that is a foreign key. So here an example is create table departments. In department we have department ID. This is one table. Then we have employee table. Employee table we have employee ID as primary key. And department ID is a foreign key. Uh, I'll share one complete schema or complete set of how. Okay, let me show you. After this, I'll show you. Okay, then other constraint is check constraint. Like I said, age cannot be greater than age should be greater than 18. Only then you can vote. In that case, it is a constraint. Okay, so check constraint we have to use. Check whether the salary is greater than 0. If you are entering a data that is less than 0, it will be showing you error. So that is one way to put some constraint on the user's input. Okay, so schema is basically, consider it as a skeleton. So suppose you have one table. So just a second. Yeah, so this is a schema of student. Schema is basically skeleton without any data. This is skeleton. So this skeleton is basically telling you, okay, the first column will have something called as customer ID, second column will have something called as customer name, and third will have something called as email ID. So this is schema of that. Schema is basically skeleton of a particular table. So to change any table, we can use the command alter table. Okay, in altering we basically can add some columns, or we can drop some column. Drop basically means to remove some columns, or we can modify the column name. So these three things we can do in altering. Okay, then we can rename the table name. Okay, so renaming is rename table, then what is the current name, and to the new old name, sorry, the new name. So these are basically the examples of what kind of language it, these are data definition language, because you're defining. Okay, then dropping the table is basically like you do not want to use this table, you use drop. So there are different things. Drop and delete will, or sorry, drop and truncate, will cover it in detail what exactly the difference. Then we have data manipulation. In this, manipulation means you are going to fetch the data. So the first basic command that will come up is select command. So the syntax is select what are the different columns that you are going to select. So you write select column 1, column 2, separated by commas, and then from which particular table, from given table, semicolon. That's the syntax of using select statement. So if I want to fetch all the data of the employees from employee table, I'll be writing select star from employees, where employees is the name of my table. Similarly, if I want to fetch the data on a given condition, so I can use select, then column name, from which particular column, sorry, table, and under what condition I want this. So I want all the names of the employees from employee table who are having salary more than 50,000. If that is the question, we'll write it select star. Star basically means all the data, all the rows from table employees where salary greater than 50,000. That's it. So it will give you the data of all the people who are having salary greater than 50,000. So then third one is ascending and descending. Suppose if you want the data to be printed in a specific order, like ascending order or descending order, we use order by. Order by is the command that is used to put your answers or arrange your answers into a given order. ASC if you want in ascending order, and DESC when you want in descending order. Suppose I want in descending order, I'll write same thing. I want in descending order, I'll write select star from employees order by salary. So it is going to order all the data in a descending order on the basis of column values salary. So highest salary will be at first, and at the last row the person with the lowest salary. Limiting, suppose you are going to check whether your query is working fine or not, and suppose there are more than 1,000 lines of or 1,000 rows in your database. So if you are going to run that query, it is going to start reading all the rows. Okay, it is going to be time consuming. Just because you want to check your code if it is working or not, you can check it even by printing just two particular rows. Okay, so you are going to limit the output. So we are going to use the command limit. We use limit and then number of rows. Suppose select star from employees basically means select all the rows from employees data table, limit 10. Limit is basically referring to how many data rows it is going. So this is going to print only 10 rows. And then we have offset command. Offset is basically suppose uh, okay, so offset is basically shifting something from one position to some other position. Suppose there is a line, okay, and I want to offset it by 2 centimeter. So it is basically shifting it by 2 centimeter. So offset here is, suppose if I write 4, so it means all the data will be printed from row number 4 and from 4 to 14, because we want only 10 data. We are limiting the output to 10. So from 4 to 14 it is going to give us. So offset is basically like which particular rows you want to start with. Then we have join clause. We will not cover join as of now because we'll be covering this in a separate lecture. It's a very big one. So in join we have inner join, left join, right join, full join, outer join. There are many types of join. So join is basically like clubbing two different tables and making one table out of it. And then we have subqueries. Subqueries means a query inside a query. Suppose I want to select all the data of employees where department ID in. So department ID in, where that means where the department ID is equals to, now it is going to solve this another query. So this is one separate query. So answer of this query is going to be used in the first query. So sub query is being uh, used when it is the output of one query is input to some other query. So that is the use of subqueries. So these are basically complex queries. Then we have data control language. In this, basically we are going to use certain constraint we are going to put on the language or the commands, where we are going to put constraint on our database by this language. So some of examples of this, like creating users, okay, assigning rows. So these are advanced things, so I think that is not required as of now, so I'll skip that part. But if you want, I can cover at the last. Okay, then we have aggregate functions and grouping. So aggregate is basically you have five functions. Count is going to count the number, sum is going to find the summation, then average, max and mean. So these five are aggregate functions. Okay, so I think this is all the theory that you need to know. I don't think anything extra you need to know apart from this for basics. And from tomorrow we'll be covering one different, just let me share. So okay, so this is one example. This is showing a company database. So in this database we have uh, employee table, and in this employee table we have employee ID, first name, last name, birth date, then gender or sex, then we have salary, then we have super ID, branch ID. So you see these blue colors are specifically only in this employee table. This orange is employee ID. It is going to be used in other column, in other tables as well, and the color suggests that this is a primary key. Then we have another table, branch. So in this, branch ID is a um unique and not null. That is a primary key for this table. For client table we have client ID. Okay, and then another table is works with. These have two different columns that are being used as primary key. And this manager ID is basically a foreign key. Okay, this is a foreign key. It is whatever is in green, this is a foreign key. Here you can see these are foreign keys. This is a foreign key. Then we have branch supplier. Okay, so this is one way to understand. And if you want to see how things are made in the chart, or you can see it like this way. uh, I think this will be covered at the last to understand like how we are going to make a schema from this and how to solve all the codes. So if you want this particular code, I'll share. So this is just to understand what is the way to make a table, how to insert data in those tables. So these data that you are seeing here, it is entered by using these commands here. Okay, so we'll be doing the practice from the next session, and we'll try to solve many questions. And one more thing I'd like to share here. Practice SQL. Okay, so we'll be using, if you search practice SQL, you will be getting this link, SQL practice.com. Click this. So we'll be using this website to practice. In this we have a database. You can see In this database, we have four different table: patient table, then we have admission table, doctors table, and then province table. In patient table, we have patient ID, first name, last name, gender, and all those things. So this golden key is primary key, and this particular key is in the gray color is a foreign key. Okay, and then we have another table as admissions, then we have another table doctors, and then we have province names. And we'll be solving these all questions one by one. We'll cover the easy one, whatever you want. We have three different criteria: easy, medium, and hard. So we can cover one by one, and or you can just practice from hacker rank as well, but we'll be doing from here. Okay, this is hospital database. You can select Northwind database as well. So in this, these are the different questions, sorry, tables. So we'll be going with hospital. And here we have all the questions. Okay, and if you want to learn anything, so you can start from here. So basic queries, in we have select statement, insert statement, delete, update, and where clause. We'll cover these one by one, and then we can cover the questions. Then filtering, we have operators, order by, like, in, between, join, all these things are there. Then we have functions. So these are the functions that we can use. Aggregate function, we have 5 different functions here: count, average, sum, max, min. And then there are Windows functions. I think that is not required for you. We can like basic functions are aggregate functions, so most of the problems get solved by this. These like these are the advanced one. If you want, you can do these. Date one I have also covered in the data type, because this is most widely used. Like you will be able to fetch the data, or like today's date, then you can find like extract the month out of it, year out of it. So this is okay. And this are the mathematical functions which you can use. And then we have tables. In tables, we have create table, drop table, alter is basically modify a table. Then we have constraint, not. So these are the different constraint and how to use them. So we'll be covering each thing one by one, and then we can go for the questions. So here are the questions here, and you can apply the filters here, like which particular you want. So if I want create, I can go with the create one. Okay, easy. So this is easy. Then we have medium, hard, and this is one of like very good source I found to practice your SQL knowledge. And this is very easy to go through and start. So we'll be using this particular website to practice. So I think that's all for today, and thank you so much. I'll upload the video, and we can watch it over there. And I request you to please go through the Python videos as well, because after completing this SQL course, we'll be starting with pandas, numpy, scikit-learn, and then we'll do the projects of machine learning, and then we'll try to use SQL in Python as well. So for that, you have to cover the Python as well and the SQL. Thank you all.